Firstly, to find the average absorbance, we type in equals to average in brackets B2 colon D2. We get the answer, and by dragging it down, we get the answer for all the other ion concentrations. And then to find the standard deviation, we type in equals to STDEV point S, and in brackets B2 colon D2, we get the answer, and dragging it down, we get the answer for all the other concentrations. And finally, for the relative standard deviation, we type in equals to in brackets F2 over E2 and multiply it by 100. We get the answer, and by dragging it down, we get the answer for all the other values. And to plot the scatter plot graph, we just highlighted the ion concentration part and then the average absorbance part. And from there, we generated the scatter plot graph for our question. And then we made some fixations to the graph, such as adding the linear trend line, displaying equation on the chart, labeling both the x-axis and y-axis, adding the graph title, and then finishing it off with adding the error bars for each of the value.
From this experiment, we can conclude the graph overview. That is, the graph shows the relationship between protein concentration, x-axis, and average absorbance at 595 nanometer y-axis. This is part of a Bradford protein assay where higher protein concentration results in greater absorbance value. Let us explain about the equation of line. Y equals to 0.0847x plus 0.3923. The slope value here is 0.0847, which indicates the change in absorbance per unit of protein concentration. The intercept value is 0.3923, represents the baseline absorbance when the protein concentration is 0. Moreover, about the error bars on the graph represent the standard deviation of the absorbance value for each protein concentration. This shows the variability of consistency of measurements across the three experiments.
For this question, we just substitute 0.973 to the equation. We will get the answer, which is 6.865 micrograms.